Keyboard, check. Pencil, check. Incredibly edgy title update, check. So this is number 3 of the computing test revision PowerPoint. So we can skip through all this, seen last time. There is quite a few spoilers. So now, representing images through code by Joe Bailey. As you know, Joe Bailey is myself. This is a short bit on how images are represented through code. So let's get going. Images. So what are images? Images are made up of individual pixels, which make a full picture. A vector graphic is made up of lines and shapes with specific properties that are stored in binary. The size of this increases, it has to be turned into a bitmap. So a bitmap is basically just a big version of a vector graphic. And a vector graphic is made of lines and shapes which have properties. So, bit depth. The number of bits per pixel is referred to as the color depth, which is the same as the bit depth. So, to work out the minimum required color depth from the number of colors to a power of 2, so you can figure it out from that. So, the number of colors with a bit depth of 6 is 2 to the power of 6. So the answer is 64 because you times all those together. So this basically shows how many colours you can get with this many bits. So if you want 2 colours, you need 1 bit. If you want 4 colours, you need 2 bits. If you want 8 colours, you need 3 bits. And so on. If you want 16 colours, you need 4 bits. If you want 64 colours, you need 6 bits. If you don't have the right amount of bits, you cannot have that many colours in a picture. So the bit depth is basically shows us to the power, by using these to the power of 2 things, how many bits are required to have a certain number of colours. So this is an example of how to find image file size. So to find the image size, you need to times the width by the height. So as we can see there, 16 boxes, 16 boxes. So 16 times 16 equals 256. And then times it by the amount of different colours, so the binary variables. So here we can see that there are 4 different colours: red, yellow, green, blue. And that basically means we times 256 by 4, because we carry that over from there. And then we have to divide the bits by 8 to make it into bytes. So we got this in bits, but we want it in bytes now, because that's how we want our answer. So we just divide 1024 by 8 to make 128. And this is basically, if you were going to put it into an equation, you'd call it W times H times C, because it's width times height times colours. Equations are often easy ways to remember things, and that is true in this. So compression, how files sizes are reduced. So compression is used to reduce file sizes and change various attributes of an image file. These attributes include file type, resolution, dimensions, and bit depth. So this was the bit depth, and it can be decreased by compression. As you can see here, the file type also may change, the resolution goes down, and the dimensions may change, and the actual image may get smaller. So compressing can work in 2 ways. It can be lossy or lossless. Lossless compression means that the file size is compressed, the picture quality remains the same, it does not get any worse. So this means none of these decrease. Also, the file can be decompressed to its original quality. So basically, you can use that to change it back again, so you can reverse the process. But lossy compression permanently removes data. So if you could convert it lossy, you can never get it back to how it was before. Well, unless you have another copy of it, of course. So here, well, lots of types of image, but this is types of things in general that are lossy and lossless. So bitmap BMP is an uncompressed still image file. So that's one that hasn't been compressed down. JPEG, also known as .jpg, this compression type is lossy. It's good for photographs. It's got a color depth of 24 bits, red, green, blue, and it's ideal for web graphics. But it's lossy, which means that things are taken away from it and they can't be re-added after it's been turned to a JPG. And graphic interchange format, GIF, I'm saying this now, GIF, not GIF, GIF, okay? Deal with it. And the compression type is lossless, which means that it doesn't lose any data. So color depth is 8 bits, 256 colors, and it's good for images with large areas of solid color. It's ideal for web graphics. So I'm pretty sure GIFs are moving images, which means they're better for areas with large areas of solid color, as then they only have to load not that many colors at a time. You can go through it quickly. That's a key difference between a GIF and a JPG and a BMP. A GIF actually moves. So the next thing we got is an MP3. .mp3, which is got lossy compression. It's audio files and it's designed for downloading music from the internet. In MP3 format, you could fit 120 songs on one CD. So MP3 has been created to have a small file size. That's its main purpose, and the lossy compression ensures that happens. So as you can see here, end of slide. Show, click to end. So that's all we've got on this slideshow, and I personally think we had quite a lot. So, okay, thank you and goodbye.